Some stock and aftermarket variators, especially Chinese-made, use low-quality drive boss bushings that may wear or fail prematurely. You may feel shuddering, unresponsiveness, or just generally poor performance as bushings wear. I've found scoring, dust from wearing parts, and in one case the bushing crumbled and I was lucky to make it home without a breakdown. This was the stock Variator from my Taotao ATM50 with only 700 miles on the odometer. In most cases of premature wear and failure that I've experienced, the bushings being used were made of steel. Sometimes they had a coating that resembled the look of bronze, but were steel underneath. I've found that replacing these with quality bushings helps to extend Variator life. Unfortunately, other parts of the Variator like the ramps, face, and guideposts may still wear quickly. The replacement bushings that I've been using have outlasted the rest of the Variator. They're oilite, oil-impregnated bronze bushings. Bronze is better suited for the job than steel, and these bushings are vacuum impregnated with oil so they contain their own lubrication. You may be thinking that oil in the CVT is a bad thing and could cause the belt or clutch to slip if it finds its way onto the wrong surfaces. That is usually true, but I haven't had any belt or clutch issues related to the oilite bushings to date. After use, I notice residue on the bushings and drive boss, but it doesn't seem to contaminate the drive faces or other surfaces to any significant degree. Here's an oilite bushing after roughly 2,000 miles of use. There is wear and discoloration, but it was still functioning fine. The Variator was replaced because the face and the ramps showed too much wear. Before the drive boss bushing is replaced, you need to evaluate the rest of the Variator's condition. There's not much point in using a new smooth bushing in an otherwise damaged Variator, so starting with a new Variator may be a better option in some cases. Begin by looking for obvious flaws like cracking or damage. Check the drive face of the Variator for wear. You may be able to feel severe wear, but you should check more thoroughly. Place a straight edge across the face of the Variator as shown and shine a light behind it. Low spots will be visible because they'll allow light to pass between the straight edge and the drive face. You can also use a feeler gauge by seeing if it will pass under a straight edge held flat against the face. I use the smallest gauge in my set that's 1.5 thousandths of an inch thick. More may be acceptable, but ideally you won't be able to even start the feeler under the straight edge. Look over the ramps inside of the Variator where the rollers travel. If they're scarred or gouged, you can try sanding them smooth or elect to replace the Variator. Check the guideposts for wear. If they are significantly worn, you should replace the Variator. Examine the drive boss. I'd prefer to use a new boss when replacing the bushing, but at least replace it if it doesn't match specs from a service manual or feels rough. You may be able to polish out minor imperfections, but that can create excessive clearance between the boss and bushing. Measure the diameter and compare to service manual specifications if polishing is attempted. If your Variator passes inspection, you'll need to find a suitable replacement bushing. You could try to take measurements with the bushing still installed, but the tolerances are very tight. You would be better off removing the old bushing and then taking measurements. I'll show you two ways that the Variator bushing can be removed. One using a press, and another using parts and tools that anyone may have around or have access to. Before either method is used, applying heat may allow the bushing to come out a little bit easier. You can use a heat gun or put the Variator in an oven and bring its temperature up to about 250 to 350 degrees Fahrenheit. Heating is not necessary, but the aluminum Variator should expand more than the steel or bronze bushing, allowing removal with less effort. If you choose to use heat, you'll need to wear thick, heat-resistant gloves to protect your hands. The first method, using a press, is quite simple. Find a thick-walled socket, rod, or pressing tool that is just slightly smaller than the outside diameter of the bushing and small enough to fit through the opening in the face of the Variator. Set the Variator up in the press, face up, center it, allow space for the bushing to fall through, and place the pressing tool you've chosen on the bushing. Use the press to push out the bushing. The other method will require a few more parts. Like the press method, you'll need to find something that is close to the bearing's outside diameter but small enough to pass through the variator. In this case, it can be a socket or even a thick washer. Then find a socket large enough that the bushing can easily fit inside of it. This will be used to catch the bushing and provide support for this D.I.Y puller. The socket should fit against the center section of the variator, so it can do this without damaging the variator. Find a bolt that is long enough to pass through the variator and both pressing tools that you've chosen, with at least enough threads left to install a matching nut. You may also need washers to make the bolt and nut work. Set the parts up as shown, keeping everything centered. Then snug the nut and bolt up so they'll remain in place, and double check that it's all still centered. Place a wrench on the nut and then use a ratchet to tighten the bolt. As you do this, the pressure should pull the bushing out of the variator and into the socket. Then you can remove the puller parts and set them aside. After the bushing is out, let everything cool if you used heat. Then clean the variator and the old bushing. Now it's time to figure out what replacement bushing you'll need, starting by taking some measurements. You should use the most accurate tools at your disposal. To do the job properly, you will need measuring tools with a resolution of at least a 0.5 of an inch, or 5/10,000ths. I would suggest using an outside micrometer and a set of snap gauges, also called telescoping gauges, for inside and outside diameters if possible. A good micrometer should be accurate to the required resolution, and this method will allow you to use the same measuring device for inside and outside diameters. This way all measurements are true to the same standard. If using two different tools, they must be calibrated to a standard in order to ensure accuracy of measurements and later clearance and fit calculations. Make all measurements with parts at the same temperature. Measuring one part that's been somewhere cold, and then another that has been in the heat, could lead to inaccurate measurements due to thermal expansion. Each measurement should be made a few times, noting each number. If you find that none of your measurements match or are even close to each other, you may need to go over instructions for using the tool and try again. It may also be due to irregularities in the part being measured. Once you have a few tries at the same measurement written down, the numbers can be averaged to provide a single measurement solution. Begin by measuring the inside diameter of the variator where the bushing fits. Now measure the depth of the bore in the center of the variator. Measure from the back side of the lip usually present on the face to the opposite end of the bore. Measure the length of the old bushing. Then measure the outside diameter of the drive boss that you'll be using. If you don't have the drive boss that you'll be using with the new bushing, you'll need to find this information. Check a service manual for stock applications. These measurements should allow you to choose a proper replacement bushing after a little bit of math. Let's begin with the most forgiving task, finding the bushing length needed. I would suggest looking for a bushing that is the same length as the old one, but it's not always easy to find one exactly to this spec. Use the old bushing length as an ideal length for the replacement. Since it may be difficult to find the exact length, subtract 5 to 10,000ths of an inch from the variator depth that you measured to use as your maximum length. It's important that the bushing does not protrude out of the variator, and the 5 to 10,000ths will allow room for staking that I'll talk about later. A slightly shorter bushing should be alright as well. I'm not sure of an exact number, but hopefully you'll be able to find something within around 5 to maybe 10% under the original length. Now let's figure out the inside diameter for your replacement bushing. Add 1/2 thousandth of an inch to the drive boss diameter and make a note of that number. Then add 1.5 thousandth of an inch to the drive boss diameter and write that down as well. The smaller number will be the minimum bushing inside diameter, and the larger number will be the maximum. This range should allow you to find a bushing with enough clearance for the drive boss to move freely without excessive play. Next, we can determine the outside diameter required for the replacement bushing. Add 1/2 thousandth of an inch to the Variator's inside diameter and write that number down. Then add 1.5 thousandths to the Variator's inside diameter and note that. These numbers will be the minimum and maximum bushing outside diameters that you're looking for to provide an interference fit, also called press fit. That's how tightly the two parts will fit together. Too loose and the bushing won't stay in place. Too tight and the bushing may not fit. The Variator could squeeze the bushing and alter its inside diameter or shape, or you could even crack the Variator. At this point, you should have 3 ranges of measurements so you can choose an appropriate bushing based on inside and outside diameter and length. I would suggest double-checking all figures. You may even wish to search machining and engineering sites for fitment information or calculators. The numbers provided in this video are what have worked for me and that have been worked out with the help of 190 mech from the 49cc Scoop forums, but they may not be suitable for every application. When you're ready to buy a new bushing, there are quite a few sources. A quick search brings up multiple online sellers. I purchased mine from McMaster Car. You may also be able to get a local hardware store or bearing supplier to order them for you if they don't stock what you need. Pay close attention to any notes and specifications listed before you buy anything. Some bushings may state their outside diameter as one thing and the true measurement may be another. For example, a 20mm bushing may actually be larger than 20mm because it's oversized as intended for a press fit. Read the fine print. Once you have the new bushing in hand, you'll need to check it to see exactly what you've got. Make sure that it fits over the drive boss and allows free movement without much play. Measure its length to ensure that it will fit inside of the Variator without protruding at all, and hopefully it's just slightly recessed. Measure the outside diameter of the bushing as accurately as you can, averaging a few measurements, and write down the final figure. You can use your last measurement of the Variator's inside diameter, but I would suggest remeasuring to be certain that the tool is calibrated the same and conditions are the same as your measurement of the new bushing. Write that number down as well. Subtract the Variator's inside diameter from the bushing's outside diameter to find out the interference fit that these parts will have. You're shooting for a 1/2 thousandth to 1.5 thousandth of an inch interference fit, or whatever specs you may have researched on your own earlier. If the bushing is too large for the interference fit that you want, you would need to find another bushing or machine it to meet your requirements. Machining to these tolerances would be difficult for the do-it-yourselfer. If the bushing is too small to allow enough of a press fit, there is a fairly simple trick that has worked for me called stippling. Stippling is basically making a bunch of dents in the surface and displacing some of the metal to create roughness and increase the outside diameter. It can be done with a punch and a hammer, but using a spring-loaded center punch has been the easiest method for me. If you use a hammer and punch, you must be careful not to overdo it. This was my first attempt at stippling when I underestimated its effectiveness. It led to a cracked Variator when I tried to press it in. Since then, I placed the bushing over a drive boss, or you can use a rod or socket that fits snug inside of the bushing. Without some sort of support on the back side, it's more likely that you push material inward and change the inside diameter. Then I use a center punch to make a couple of rings around the outside of the bushing as shown. Check the diameter of the stippled areas when you finish. I've had no trouble even when an area is oversized to as much as 0.03 of an inch interference fit after stippling this way. Doing only a couple of rings seems to be more forgiving than changing a larger area. Recheck the fit of the drive boss as well to make sure you haven't deformed the bushing. Another way to keep a slightly under-spec bushing in place is to use a chemical bonding agent. An example is Loctite 603 retaining compound, but there are other options. I've been using retaining compound even when clearances are correct and after stippling has added insurance. Some variators have a step near the face where bushing diameter must decrease. Unless you find a direct replacement bushing, you will probably have to modify what you have to fit. I just used a grinder to remove enough material to make it fit quickly without much concern for precise fit in that section, but by all means use more proper and precise machining methods if you can. Once you have a suitable bushing and the details of its fit worked out, you can get ready to install it. Make sure the variator and bushing are clean and dry, and heat the variator as described earlier if you choose to. Don't forget gloves to protect your hands if using heat. You could also cool the bushing for a greater effect. If you'll be using retaining compound, apply a small amount to the outside of the bushing and the inside of the variator just before they're assembled. Again, I'll show you two ways to install the bushing. One with a press, and one with just nuts, bolts, and washers. Let's start with a press. It's a straightforward operation using a press. Set the variator in the press face down and put the bushing in place as straight as you can. Then use a socket or other tool to press the bushing in. Here I used a piece of wood to get it started and then used a socket small enough to fit inside of the variator's bore to finish the job. Push the bushing all the way up against its seat near the face and stop. Pressure beyond this point will only risk damaging parts. If you want to do this job without a press, find a thick washer that is just smaller than the diameter of the bushing. Get a bolt long enough to go through the variator and bushing with room left for installing a nut and washers, and place it through the variator, bushing, and washer as shown. Add a thick washer on the opposite side that's substantially larger than the hole in the variator, then install a nut. Hand tighten the nut while you keep the bolt, washers, and bushing centered. Once you have it finger tight, verify that it's centered to the best of your ability and then tighten it with wrenches or a ratchet so it's snug, and once again make sure the assembly is centered. Then you can begin tightening the nut and pulling the bushing into the variator. You should feel it as the bushing seats against the face. Stop there and remove the bolt and parts to verify that the bushing is all the way in. If not, set it up again and finish pulling the bushing in. After the bushing is seated in the variator, clean off any retaining compound that has been pushed out. Let it cool and then slide the drive boss through the bushing and check that it still moves freely. If it doesn't, you may have used too much interference fit or disformed it during stippling or installation. If everything checks out, you can call it done, or take one last precaution to prevent the bushing from moving, called staking. Staking is a way of displacing a bit of metal to further secure the bushing, and all you need is a hammer and a punch. Place the punch on the back of the variator as shown, holding it at a slightly inward angle. Then tap it a few times with a hammer. You don't need to beat on it, just use enough force that you're making an indentation. Repeat the process a few times in different spots around the bushing. By now you should have a secure bushing. Once again, make sure everything moves freely but without a lot of slop. If you use the retaining compound, give it 24 hours to set up, and then your variator is ready to use. Thank you for watching. Please subscribe for more videos, and like and share if you found it useful.